Hi, this is Ruchi, and in today's video, we will be talking about recursion. In our previous video, we already talked about what is a recursion, what is the recursive definition of a problem, and how we can implement recursion in Python. But if you remember, we have also discussed about this factorial problem, but we have not solved it in Python. So today we will look into this thing, how we can solve this problem in Python. So the recursive definition of a factorial problem is n factorial is equal to n multiplied by n minus 1 factorial. So let us implement this in Python. So to implement this, we will define a recursive function. So let's use this keyword def, and the function name, let me keep it as factorial. And now, definitely what will be the parameter of this function? N, which is the number for which we want to find the factorial. Now, what will be the return statement? So the recursive definition says that n factorial is equal to n into n minus 1 factorial. So this is the thing which we will be returning. So we will return n multiplied by factorial of n minus 1. So this is the function definition for factorial 0, 0 factorial. Now, another important thing that you must be remembering, that is we need the base condition. So base condition is what? Base condition is the smallest step of the problem for which we know the answer. So what can be the base problem of factorial? As we know, factorial is nothing but multiplication of the number and all the number from 1 to 1 up to that number. So in case of 1, what will be the answer? So 1 factorial will be nothing but 1. And if we say what is the value of 0 factorial, that is also 1. So we know the answer for 1 factorial, 0 factorial. That is why we can add a base condition saying if the number is less than 2, then return 1. So if it is less than 2, that means if it is 1 factorial or 0 factorial, it will be 1. The result will be 1. And hence, this will work. This is the base criteria. So once the number reaches 1, it will be breaking the entire recursion. So let us see how it works. We will be copying this, right? Now, let us check for some number, let's say 10. Let us see what is the value of n factorial. Okay, there is a mistake. I have put it as n greater than 2. It should be n less than 2. When n is less than 2, then only return 1. Now it should work. So here we have the answer. But how we can validate this answer? Let us run a loop for validating this. So validation. So the loop will do what? It will multiply all the numbers from 1 to 10. So for I in range n plus 1, it should start from 1 and it will end at n. So let us also verify whether we are taking the correct thing or not. Print list range this one. Okay. So here you see we are getting 1 to 10. So this range 1 to n plus 1 is correct. Hence, what we will do, we will be running this loop. Again, we will take this as the result and we will print this result. Here we will write expected output. Here we will find the multiplication of all the numbers starting from 1 and ending with 10. So ending before 11. Let's see what is the output, whether it is matching or not. So let me run this. Here you can see the output of factorial 001 function is 3628800, whereas the expected output was 362828800. So this is matching with the expected output. So our factorial function is working perfectly. Let us verify with some other number. Let's have 5 here. And let's run this cell. So here you can see the output is also matching for 5. And what are the numbers which have been multiplied? That is 1, 2, 3, 4, 5, which is correct. So this is how we can convert any iterative problem into a recursive problem. One more thing I want to mention here is, here we are calling the factorial 001 function directly from inside this function. But it is not mandatory that every time if this function needs to be a recursive function, we need to call itself from the body of this function. We can also call another function which will be again calling this function. That means it can call itself indirectly also, and in that case we will be calling it recursion as well. So let me show you such scenario. Let's say we have a function 1. Okay. Now we have to define this function 2. So if we have something like this, this function 1 is again becoming a recursive function. You don't need to understand this logic. This is a dummy logic. But what you need to understand is, here what is happening. Function 1 is calling function 2. And function 2 is again calling function 1. So this again becomes a recursion. Because what is happening? Function 1 calls function 2. So this again calls this function, which becomes a loop. So in the other function where we had this, so in the other function, which was this factorial 001, in that case, what was happening? This factorial 001 was calling itself. So there was a flow which was like a loop. And here also we have function 1 which is calling function 2, and again function 2 is calling function 1. So here also it creates a loop structure. So this is also recursion and this one is also recursion. So both of them are recursions. So that's it for today, guys. I'll be ending this series with this video, but let me know in the comment section if you feel anything any topic I need to cover. So I'll be covering that and I'll be adding new videos to this series. Thank you for watching. Keep learning, keep implementing.